Good afternoon,
Good afternoon,
everyone.
everyone.
I'm Sim with AABC, and I'd like to welcome you to today's Tab Talk webinar. I would also like to thank our sponsors, Integra Testing, for supporting this session. Integra is a trusted partner in building performance, combining national expertise with a local touch to ensure safety, compliance, and efficiency. With over 500 trained professionals and proven testing methods, Integra delivers reliable results you can count on. Just a few items to get covered before we get started. Presenters will be holding the questions until the end of the presentation, but we encourage you to submit them at any given time using the Q&A button. If you happen to be experiencing technical problems during the webinar, please use the chat function to inform the panelists so that our producer Will can assist you. This presentation is being recorded and will be available for viewing in 1 week. In terms of the CEUs, that is the continuing education credits, everyone in attendance for the full webinar will receive a certificate of attendance sent to their email within 24 hours. And finally, if you are a certified TBE or TBT, your CEUs for attending this webinar will be automatically uploaded to your respective portals after the webinar. Today's webinar is Pre-Demolition Readings. Please welcome today's speakers, Eric Grundmeier and Tim Nuckols. Eric is a general manager of RSAnalysis, an Integra company. He started as an apprentice in 2012, became a certified TBE in 2017, and now leads the team focusing on growth and making things better every day. Whereas Tim Nuckols, a certified TBE with 42 years in the HVAC and test and balance industry, serving as asset manager and safety director at Integra. Started his journey as an apprentice in 1983. Tim now leads safety programs, trainings, and risk reduction efforts across job sites. Without any further ado, I'd like to hand it over to the speakers to kick us off.
Thank you for those introductions. Good morning and good afternoon to everybody. So glad that you guys could be here with us today. Tim, go ahead and get us kicked off on, you wrote an article for the AABC Tab Journal about pre-demolition readings. Share where that came from.
Well, basically a couple years ago, needed to get a tab article in, and was going through my head various topics and so forth, and we had just been given, me and a couple other guys that mainly were in the office were approached on taking this pre-demolition job on to help out the other guys in the field that were right busy at the time. So we jumped in and got with the mechanical contractor and gathered up information and had a little meeting to come up with a game plan. And before you know it, we were running through a high school, taking hot water readings and various other pre-demo readings, and basically we're just thrown right in the middle of it there. So that's where this article came from, and turned out, like I mentioned earlier to William, that I learned a lot more and realized there was a lot more to the pre-demo part of TAB than I really realized. So I've learned a lot even after writing my article.
Yeah, thanks for sharing that. I mean, one of the great things, and as your introduction said, you've been in this industry for quite some time. I think since 1983 is what your bio said. And there's a lot of lessons learned in that amount of time. And I think that's one of the great things about TAB, this industry, is that we get to share experiences, lessons learned to make us all better. And pre-demolition readings or pre-balance readings, I think is something that we all do, whether it's called a survey, and we'll get into that. But there's a lot of lessons learned, right? And it's great that we can be able to share those. So thanks again for Integra sponsoring this, and we'll get started here. So pre-demolition readings, the process of taking airflow and system performance measurements before mechanical equipment or ductwork is removed, replaced, or modified. So typically in pre-balance or pre-demolition readings or pre-balance readings, we are trying to create a baseline for the existing system that is there. This way that we know how the system was functioning, especially if they're going to reuse the equipment or the ductwork. Sometimes they're going to use portions of the ductwork. Sometimes they eliminate it all, but they just want to know what the fan can do because maybe they're not replacing the fan. So we're taking a snapshot in time to say this is how the system is performing before we make those modifications. That way, if something doesn't happen, in the theoretical realm where an engineer is taking the system and then modifying it, if it doesn't happen on the back end of that, right after the construction process is done, we have these pre-readings to go back to and analyze that data. And so I know you had some experience with that too, Tim, right?
Yes, sir. All these readings were taken and notes were taken, especially. I can't underemphasize or overemphasize that enough. Notes and various readings were taken, and all these numbers go in and are very important for the engineer to make their next move on new equipment and how everything's going to be designed. So very important, that's for sure.
Yeah, and one of our last points here is it protects all parties. I mean, that's the other great thing about having the data before we made any modifications is that we can go back and look at that data and analyze, what happened to the system. It's protecting us to say, if we didn't have this, if an engineer, for an example, created or designed a project for 10,000 CFM, but we went out and we measured that existing equipment and it only could achieve 6,000 CFM, we already know that the project, needs to be re-looked at. So these are all the things that help protect all parties involved, and it's very important. As kind of mentioned in the very beginning of this, we're focusing in on basically a survey or a pre-demolition reading report. And really, you can call it many different things. Pre-demolition and pre-design surveys are specific to what are the next steps that we're taking that report for. So in a pre-demolition reading, I mean, it's pretty self-explanatory. We're taking it before they do any demo of the ductwork or equipment of that space. If we're doing a pre-design survey, it may be just before, information for the engineer to make decisions. But we can also call it a survey. We can also call it a pre-balance. It's all the same work is really what we wanted to point out here is that we are taking a snapshot of time of existing equipment. We're not making modifications. We're not balancing. We're not adjusting dampers or anything like that. We're going out there and we're taking existing snapshot of that equipment. And sometimes there's caveats to that the engineers want to see, if there's VAVs on the project. We've been asked before, can you open those VAVs 100% so that we know what the maximum amount of airflow we can get out of that VAV? Now that's at a given static, right? So if the air handler is operating at a 1 inch of static, we want to know what's the maximum amount of CFM at a damper position of 100 we can get out of it. So that's some information for them to help with the design. But these all are kind of interchangeable. Pre-balance survey, demolition reading, pre-design surveys, they're all interchangeable as a reference to the kind of the same scope of work. Just it may indicate what is the next phase, just like we talked about. With going out there and performing this work, and I'll let Tim expand upon this, we may need to coordinate with other trades, whether it be the controls contractor, the mechanical may be involved at that point, the MEOR. We may need site access to the facility. And so it's important that before we go out there that we understand what is being asked of us, and what other trades are we going to need with us in order to complete the scope of work that's been outlined by the mechanical engineer. So go ahead, Tim.
I guess something here to bring up, Eric, and we may have spoke about this earlier. If you've taken 5 pre-demo readings on 5 different projects, there's a good chance that every one of those scenarios was a little bit different. It could be the size of the project makes a difference. In the case of the article that I wrote for the Tab Journal, we had a high school, so we pretty much sectioned off different areas, and we put them, had the control contractor do a global override, so we could pretty much go VAV box to VAV box, reading the hot water flow. When something like that happens, and I think we'll speak of this in future slides here, but the comfort of existing areas that people, occupied areas, may come into play if you were to dump a hot water system, let's say, or even dumping an air handling unit to full cooling. Maybe chillers or boilers will have to be turned off and different things manipulated, but it could be a differential, a pre-demo reading of a couple VAV boxes, a few grills, all the way to entire hot water system, chill water system, various air handling units, multiple VAV boxes. So each of these projects is going to have some planning, and obviously communicating with the control contractor, the mechanical contractor, going over exactly what the engineer is expecting of us to get out of these pre-demo readings. So all of that is very important and can change from project to project.
Absolutely. And, one thing for us in particular, having the controls contractor there, coordinating with them, it creates, we're dealing with existing systems that may have issues or problems that we don't know about yet. So having the controls contractor there in case something happens, if the system goes down, or, a lot of times we create overrides, right, within the tab industry to manipulate the system in ways we need it to take the readings. I like having the controls contractor there, so they're putting in the overrides, not myself or our technicians. That way, I'm not held responsible when the heating valves were left open overnight and everyone comes into 100-degree space temperature the next day. So it's a way of helping kind of facilitate and manage risk, especially when you're dealing with existing equipment. Having them there really kind of gives you that safety factor to not put all liability on the tab contractor. And it also expedites, because a lot of times we don't have the ability, like you talked about, to do global overrides, right? So that can definitely create efficiencies for us to get through a pre-balance. Having the tab contractor there, being able to do global overrides or get into the system and manipulate it. And one other thing, to document set points is another great aspect to have them there, because it's, hey, can we take some snapshots? Can you give me some screenshots of how the system is operating? It's a great reference to go back to at the end of the project as well, to say, hey, look, I have a snapshot of when we took these readings, and this is where the fan was operating from an RPM, from a static, from a flow. And it's great to have that reference to look back on. This was something Tim brought up, and I thought this was a fantastic slide. Working with legacy balancing devices. This is something that we all run across. We run across it not only in pre-balance or pre-demolition readings, but sometimes we're doing a final balance with existing old components. One of the things Tim and I were talking about earlier today actually was having the understanding that it is the tab contractor's responsibility to find this information. We're using the charts, we're using the curves. We need to be able to find this information to utilize while we're taking those readings. So we're taking a pressure drop across a balancing valve on the heating hot water side, right? So we need to find those charts. And a lot of times Google has been a great resource, or the manufacturer. Tim had some examples of him contacting manufacturers to get information. Go ahead, Tim, and expand on that.
I guess when we both talked about possibly some of these companies not being in business anymore and being able to reach out to the company that bought them out or that owns them now, and possibly giving them a serial number or some type of model number, and them possibly having a library of themselves that they could dig up this information. Going back to my article, one of the things that I was lucky enough to do, and I told Eric, I've got a couple if not 3 or 4 pretty nice sized binders full of graphs and charts and curves. And in the article I wrote, I was able to refer back after searching the internet for this information and not being able to find it. Was able to find some graphs and charts that we used on this specific project. So I guess somebody probably told me, or maybe it came automatic. It is kind of common sense when you run across these charts and stuff, which is what we did back in the day. Now you pull up these charts and graphs on the internet. Back in the day, we had the hard copies and the binders, carrying them around with us. So kept a lot of those, and they have definitely come in handy.
Yeah, those things are worth their weight in gold now. Absolutely. We have some old Palm Pilots in I think they're called the VBT 1400s from Johnson Controls that we still deal with some older Metasys or N2 at JCI. And, those components, maybe worth, $100 now, but they are priceless in the tab industry. And I think the documentation that you guys have saved, I'm sure most of us in the tab world have saved some of that documentation over the years, but it's so interesting when you get a job that has older equipment, you can go right back to it. They have that information. What a great way to, save in libraries. And as Tim talked about, I've done the same thing. I've contacted manufacturers before and thinking there's no chance, this equipment's 20, 25 years old. There's no chance they have documentation on it. And it's been so surprising what these companies have databased over the years. I definitely encourage, if you cannot find it in a quick Google search, that you call their support line and ask for the documentation. More of the times than not, they've been able to find it for me, and it's been just so helpful, especially while trying to quantify flows and look at, what was this equipment designed to do at the time that it was installed versus what are we seeing now. So definitely highly recommend. Google is also the best resource. I don't know how we ever did it without it. Test and balance, that is. One thing, we brought this up, just some challenges, things to look at when we're dealing with hydronic flows in pre-balance readings, and this just has to do with age of systems. So as we see these older systems, depending on the materials they used, for install of the piping, there may be corrosion and buildup. So we have to be very careful about when we're taking those readings to understand that there may be things happening inside that pipe or that hydronic system that we cannot see. Fortunately, when we get to deal on the air side of things, we can open up doors in the air handlers, we can look at coils, we can see if they're clogged, we can drill holes in ductwork, we can do all types of things to see what's going on inside the system. Unfortunately, if we did that in the hydronic system, we'd have a big mess on our hands and lots of water on the ground. And so, we have to just be careful at older components. If we're taking pressure drops across coils, if we're taking pressure drops across components, chiller barrels, there may be corrosion that's happening, and that's going to manipulate how much pressure drop we're seeing at a particular flow. So we can't always reference back to that design data. We do have to kind of look at it from a multiple standpoint. So, we talk about this quite often, is that having multiple sets of data within, when you're doing test and air balance, it definitely can help, because then you're taking two different sets, and if they equal each other, you can feel pretty confident that that's the flow that you're getting. When they don't equal, then you have to do some troubleshooting to figure out, okay, what's happening? Why do I have this reading that doesn't equal what I think the flow should be? Have you experienced anything, Tim, in over your years of aging systems where, something, you took some readings and you thought that it was going to be one thing and turned out to be the next, and something surprised you along those lines?
Yeah, I can't recall that specifically, Eric, but no doubt that in the back of your mind, when you take these readings and they do not come close to design, double check, maybe take another set of readings like you talked about if the system's up and running in a normal under control, then maybe a temperature, entering and leaving temperature of a coil along with the flow reading, if you can get both of them to match up, that's always a good thing. But there's no doubt that after 20, 30 years, there's going to be some integrity issues with the piping. Once again, like you mentioned earlier today, the type of pipe, what they did 30 or 40 years ago is not exactly like they're doing now. So older stuff, older equipment's definitely going to be giving you some bad readings because of the integrity of the equipment there.
Yeah, absolutely. And then one of the other things that we brought up in these points too is the lack of verifiable settings or markings. I mean, how many times have you gone out to maybe an air handler that has a tag on the side and it's been bleached out by the sun, right? Now you can't even read it. You got to find another serial number somewhere. And so, and that happens too. How many times have I have an example of it right here, actually, when the Bell and Gossett, knob's missing. It's like, what is this, right? How many times does that happen where you may not have, the indications on it anymore of where the setting is at. And so you got to get creative on how you can take those readings. How do you quantify that flow? Sometimes that we get into the mode of having to bring out an ultrasonic meter to verify those things. So there's definitely more, multiple ways to skin a cat. So this was also one of your slides too, Tim. Thought this was great to bring up retro commissioning. And so just kind of how we use, we're calling it pre-demo, but really kind of pre-balance, how we're using that information in retro commissioning to maybe make some adjustments or what is that going to do for that project in retro commissioning?
Our commissioning director was kind enough to give me a page or two of notes. This isn't something that I have personally been involved with to any extent, but he gave me several notes about, and I guess the last note on this slide being the most important, just coordination between the owner, engineer, commissioning agent, and tab contractor is essential to avoid rework and scope gaps. Even though time is of the essence, just about every pre-demo project, the mechanical contractor wants you in and out so they can start tearing stuff down. If you are not all on the same page, if the specs are not clearly, they don't clearly define exactly the readings that you need, and if this is not taken seriously, it will come back to haunt you. So once again, some of the notes he gave me were basically communication and to take this seriously, and any extra notes and comments you can make to make this go easier while you're taking your readings is going to help out in the long run for sure.
Yeah, and in a retro commissioning effort, I mean, one of the great things about doing a pre-balance is finding out the actual condition, right? If you're having issues, if office spaces are hot or if they're cold, if whatever's the issues that are happening, usually there's something happening within the space or the building that they're like, hey, we need to bring in retro commissioning. So taking that snapshot in time to say, where are we at now? Because we do know, over time. I mean, one of the best ways that we stay in business is that the engineering staff goes around and changes dampers, right? They're opening dampers, they're closing dampers. This person's hot, this person's cold. They had a problem with a heating hot water coil, so they just shut it off because it was open, it was stuck open. Whatever those things are, the great thing to go do is take a snapshot. Okay, we have a problem child or a problem room over here. Well, yeah, we found that the heating hot water coil was closed, right? So of course you have a problem. taking that snapshot, being able to compare it to what the design criteria were. Hopefully we can find that information, but, you know, going through old plans, mechanical plans, and referencing those against the readings to kind of come up with project scope. Also, you know, what does that balance scope look like in retro commissioning? You know, taking that pre-balance as kind of the kickoff event will give you that snapshot so that you can start making decisions on what that project scope may look like as you move through retro commissioning. Documentation, you know, this is part of the reason we're even, you know, doing pre-demolition, pre-readings, surveys, is that we need to document the unforeseen, right? So a lot of these I know Tim put in here as examples. You know, are we finding, what are we finding? What is not working? What is, you know, leaking? What is, you know, turned off? Those type of things. It's great information to, you know, we get one chance at this, right? Because especially in a project where they are demoing the system, maybe all the ductwork, and they're leaving the air handler intact. When that happens, we get one chance at this, because after that, the components are gone. So we need to make sure that we're documenting, you know, what's happening in the systems, you know, and what we may encounter on the backside. I know you had a couple points in here, Tim, about, you know, the water ports that you found and airflow monitoring stations. You had some examples of stories over there.
Yeah, so going back to my article, and this was 160 existing VAV box hot water coils to speak to the water balance inside. We found out very early that we were not going to get a reading off of every one of these combination circuit setters, auto flows, various companies, manufacturers, and early on, whether they were valved off, like Eric spoke of earlier, running into stuff like that, valved off, not getting flow through the port. If they're installed incorrectly, and this may have been 30 plus years ago, if they're turned upside down with the ports are facing down, then obviously sediment is going to settle in there. And you have to decide how much time you're going to try to bleed this water off of this valve and get the air out so you can move on to the next one, because once again, time is money, and the mechanical contractor wants these readings so they can move on. And you have to do your best to get the best reading you can, but depending on the age of the equipment, the fact that regular maintenance may have not been done, it's just all that comes into play, air and water, whether you're going to get a good reading on flow rings, auto flows, circuit setters, and you just have to make that decision on the spot to do the best you can and move on to the next piece of equipment if you can't, because of a failed piece of equipment.
Yeah, and documenting, we'll talk about this a little bit later, but pictures are fantastic, right? I mean, taking pictures in a pre-balance, you know, when you're doing a pre-balance is critical, because it's a reference for you to go back, especially after demo has taken place, and you can go back and point to certain things, or, you know, maybe there's nomenclatures or things that you can record. I know that we've always, you know, when we've had those in our back pocket, and engineers ask us for certain information, or where did you get this? I mean, pull out a picture and say, hey, here's some pictures we took on site, has been just invaluable. So I got the little whiteboard on here saying your last chance, right? So we get this chance of a snapshot in time to record this information. And once we move on to the next phase, whether that's demo, whether, you know, whatever we're moving on to in the phase of the entire project scope, we get one chance to get this information, because it's more than likely there are going to be changes and adjustments that are made right after we take these readings and submit the report that we're not going to be able to get back to the same condition. So some things to look at, guys, is making sure that we're getting set points. We're looking at the fan data, that we're making sure that we're completing our work on site, that we're not, or, you know, a lot of times guys will write stuff down in notebooks, or they'll put stuff on pages and then they're, oh, I'll do the report later. And one of the big things that we've been pushing is, hey, you do the report before you leave to make sure that that's all filled out, because we're going to get the one chance at this. And if we move on, we're not going to be able to come back and reestablish these same conditions. Assumed operations, I have some stories to all of these that I was going to point out. Do you have anything to say about these one, Tim?
I guess the photos are one thing that maybe I have not used properly in the past, but is a very good point. If you can take photos and document what they're a photo of, then I cannot see that hurting things whatsoever. That's something that I really, and I don't know if our guys in the field do that now or not. It's been a while since I've been in the field, but photo is a very good point that you made there, and something that I did not take advantage of on a normal basis.
Yeah, and I think that's evolved over time, right, Tim? I mean, back in the 90s, we didn't have, you know, cameras on our cell phones. So, you know, it's definitely evolving over time. We're using technology in different ways. Now we all have a camera in our back pocket we can pull out. It's unlimited. We're not going to have to go get it developed. So it's not like your camera roll is, you know, limited to 25 pictures or anything like that. So we've encouraged our guys, you know, use up that space, take as many pictures as it seems like is reasonable. And we always seem to, you know, it's never hurts us, I guess, is what we've always gotten back to. It's never hurt us to have more pictures than not, and especially something you can go back and reference when it's no longer that same condition. So one of the ones we brought up was missed set points. So I had a story here of a project we had, probably similar to many of you. You know, we had a specific space. The scope of work was really just diffuser inlet and outlet readings in a hospital. They gave us the area at which they wanted us, you know, the highlighted area. Go read all the diffusers in this area. Okay, the back end of this, the post balance or final balance, was going to be 2 rooms that were modified, and they needed to small adjustments, probably under 100 CFM for the total for each of the rooms. But we went and measured all our pre-balance readings, established, you know, basically here's the baseline. They did the work. We came back. We're 25 to 30% lower on all of our diffusers. And of course, you're going to point to the air handler. The air handler must not be operating at the same RPM or the same static. Something happened to the air handler if we're 25 to 30% lower. Well, we didn't have the readings. We didn't go up. We didn't take statics. We didn't take a snapshot of the BMS. We didn't know what, you know, the RPMs were. We didn't have any way to reestablish what the air handler was doing at pre-balance, because the scope of work didn't identify it. It wasn't in our scope of work when they outlined what they needed and what they were requiring of us. That wasn't in our scope of work. So one major component here, what I'm encouraging everybody, it does not take long to have a technician go up and grab that information, even if it's not outlined in the scope of work, but it'll save you heartache on the backside in case something does change. So whether the engineer, the MEOR says, hey, go get that, it's just mandatory at RSAnalysis that says you will go get that, because we've had too many times where something changed and we can't identify because we don't have the information. So this was just kind of a follow-up to that one, but just that we didn't have a baseline of the air handler. We didn't have, RPMs or static or any way to identify, like I talked about, what the air handler was doing at that time. So even though it may have looked like a simple read and record of the space, it turned into a bigger project, because now we're dealing with trying to reestablish air handler. We're trying to look at trend data that, limited trend data of what the campus had of the hospital, but trying to reestablish what that fan was doing prior. And the other thing that comes up in that too is that when we don't know, we didn't take pre-readings of the entire air handler, right? It was a specific space. And so now we're making adjustments to the air handler, and we didn't have that out of scope or out of construction boundary readings. We only had within it. right? Because that's all that was required. So you do have to make some assumptions when you're getting everything back to that baseline in that specific area, without having those readings outside of that area. Then it does kind of create this uneasiness that you may be making changes to other areas. So of course, in that circumstance, especially in a hospital, we're going to all of the critical spaces. So if an air handler has an isolation room, if it has soil utility, clean utility, ORs, any of those, what we would deem clean spaces, we're going and checking those, especially since that we made adjustments to the air handler.
I guess one thing, Eric, just to emphasize one more time, because I feel like I'm guilty of this, and I feel like it's part of a mindset to go out and make sure you do not go out of your scope of work. Don't do anything extra, but in fact, taking that extra check at the unit to see what the speed is, maybe an RPM, maybe an extra static pressure, anything that can help you at the end of this project. If it takes a few extra minutes, even though it may not be in the specs or in your scope, is a very, very good idea. And once again, I'm guilty of maybe not taking a couple extra steps to help me out once this was all done. But that was a very good point.
Yeah, I mean, lessons learned, as we talked about in the beginning, it happens to you once, and then you're like, hey, it's a good idea to do this every time because, I don't want to deal with this again. And, to take an extra 15 minutes to get up and grab some information or even a snapshot. I mean, at a minimum, take a snapshot of the BMS if they have a BMS system and say, give me what the conditions were at the time we took these pre-balance readings. That way, even you could reference back to that. I like to go up to the unit and check it out myself and take some readings. It just gives you that peace of mind that, especially when you have to reestablish the pre-readings, the post balance, it gives you that peace of mind that that you can reestablish, or you can point to what happened, right? A lot of times, we live in an invisible world in test and air balance, and we say something changed, and everyone's looking like oh yeah, like maybe you guys never came out here and took your pre-readings, right? Maybe these are falsified, and without another point of reference, it's hard to just navigate through that. So that having that point of reference to say, no, look, I took this point of reference, it was 1.2 inches of static, and now it's 0.8 inches of static. Something changed. So
I would say documenting outdoor conditions may come in handy also.
Yeah, if the air handler is an economizer, if it's a minimum outside air, we've seen changes too. If you have a restrictive return air, damper, sometimes we have restrictive return air dampers, and that will adjust how the flow, what happens down in the space. So it's a great idea. Outside air conditions of the air handler, BMS snapshots. Highly recommend that you get that, whether it's part of scope or not. Incomplete data. So this was another reference we had to just kind of talking about making sure that we go through and get everything. And this wasn't a case, the scenario that I put on here was not a case of we were at fault, like we didn't grab the information, but what ended up happening was they performed demo without scheduling us out there to do the pre-readings. So now we have zero baseline for the facility, and it was a pretty substantial project that went 2 floors of a hospital, and they didn't call us out there. They moved forward with demolition, got the demolition done, and realized they never did the pre-balance. Well, now they're calling us out there, and they're like, oh, can you get the pre-balance done now? It's like, you've already done demo. The system's changed. I don't know what it was. It's not like they're going to go reconnect all the ductwork and, diffusers and everything else. Like that was already said and gone. So now what ended up happening in here in California, we have what's called OSHPD or HCI, and they oversee all hospital construction. They're an overseer of the state of California that oversees all construction. So to get through a construction project in a hospital, you have to get through OSHPD. OSHPD came back and said, since you did not establish your pre-readings prior to construction or demo, now you are responsible for going back and reestablishing the latest design CFM for all of those areas. So we ended up having to rebalance 2 entire floors, supply exhaust and return on 2 entire floors, because they did not call us out to do pre-readings to reestablish what that airflow was at post-construction. So that was the resolution. Ended up causing delays, ended up causing change orders, because they just didn't follow suit. So not a case in which we didn't complete the data, but it was a case of which, the data was never taken prior to demolition, and just how important it is to make sure that we're communicating with the construction team, making sure that, these things are happening in sequential order to make sure that this doesn't happen, in the future. Just real quickly, guys, just don't assume. Don't assume any kind of operation of equipment when you're doing pre-balances. We had a situation once again in a hospital where they needed to increase return airflow in one particular space. Went to the air, went there. The MEOR had asked us, hey, can you ensure that we can get this return air out of this one diffuser? It was like an increase of, I think, 80 to 85 CFM. We were incredibly low. I think they wanted 350 CFM. We were like 80. And they're like, can you make sure the damper's open? So we opened up the damper. It was already 100% open. So we had to explore and continue to explore, okay, what's going on with this return system, right? Is there a closed fire smoke damper? What else is going on? How is this one diffuser supposed to be 350, only 80, and we need 80, 80 CFM more than that at the post balance? Well, that led us all the way to the air handler. Once we got to the air handler, we realized that the fan had been operating backwards for over 10 years. They replaced the motor. They didn't do the polarity right, and the motor had been operating backwards for over 10 years. So of course that expanded our scope into, finding this issue, having to reverse polarity, and then going back and, rebalancing the return system. So interesting, don't assume that everything is just operating correctly, go and verify for yourself. Just real quick, guys, this was an example of a scope of work that an engineer has given to us. They've gotten very good at giving us, specifics. So they go through the plan, they mark it up, they put their notes on there for exactly what they're looking for in a pre-balance. It's been very helpful. So just an example of what we can get from, an engineer on, what they may be looking for.
It's not exciting reading, Eric, but you definitely need to check every demolition sheet, because there are notes, could be on the border, just about anywhere on that page. So going through those notes is very important. That's a good thing to say there.
Absolutely. And Tim, you're spot on. Reading through the specification, reading through the notes when you're going out there. Once again, as we talked about, it's your last chance, right? If you don't do it and then find out, go ahead and do demo, you're not going to get the chance to go back. So getting the information the first time, making sure you're combing through it, that you find all the pieces of information and data they're looking for, is important. And one other, component that we'll talk to real quick at the end of this is that keeping the engineer involved, right? Communicating with them while you're on site, calling them and saying, hey, I'm here on site. I had a question about this. Give them the opportunity to maybe, point to a few things that maybe they saw when they were going through identifying what they wanted in that pre-balance. That line of communication with the engineers is so important. And it can, once again, like we've talked about in many of these examples, can save you a lot of heartache on the backside of it, because you're having those open lines of communication and making sure you're crossing T's and dotting I's. I'm going to go ahead and, time's sake, looks like, Tim and I were worried we may not have 45 minutes on this, and looks like we're hitting our limit here pretty quick. But this was just, what I wanted to point out here was the fact of multiple ways pre-balance information can be used. We had some projects come out in the last 5 years where they have us trending domestic hot water to resize either the heat exchanger or the boiler for the domestic heating hot water systems. What we have found, a lot of these are buildings have been operating for 10 to 20 years. And it was all based on, theoretical. It's, hey, we have this many showers, we have this many sinks, we have a kitchen, we have, this is what we think is going to be the water usage, domestic hot water usage. But it's all theoretical at that point. So what they've had us do is come and trend for 2 weeks of the heating hot water system with an ultrasonic meter and data loggers. We can look at peaks, we can look at average consumption, all of those type of things. And what we've found is that a lot of these boilers and heat exchangers were 30 to 40% oversized because they're putting safety factors in. They didn't know what the consumption is. Well, guess what? Now we have the ability, as the system is operating, as we have people in the building, to look at it, and they're able to resize these boilers, heat exchangers, to the appropriate size, one, reducing cost in the replacement of the units or the equipment, but also energy consumption. They were able to bring down the energy consumption for that heating hot water because we're not oversized anymore. So just another example of a pre-balance where we can gather real data that's happening in these buildings and how it can be useful to engineers and projects as we move through. Keep the end in mind. I talked a little bit about this, with the return air, but just, think like an engineer. If you're going out there to do pre-balance readings, and Tim said this, and it is great. He said, read all the notes, right? I go even beyond that, read all the notes and read the final balance, right? Where do they plan to get to at the end of this? Understand that, hey, I'm taking pre-balance values right now, but where do they want to end up? What are those design values? Are they changing? Are they adjusting? Are we reading now in our pre-balance that we're 200 CFM low from what the final balance is? That's something I should flag. That's something I should call the engineer on. That's something that we should have a discussion about, because guess what? When I get to the end of the balance and I'm trying to find that 200 CFM that never existed at pre-balance time, we got a problem on our hands. So keep the end in mind. Think like an engineer, read through the entire project phasing to understand where we're going to end up at the end of it. And this was the last slide, guys. Just creating a feedback loop. We've talked about it, but just is, make sure that you're communicating, make sure you're getting your reports, make sure you're sharing your findings with the construction team, the MEOR, that they understand of any obstacles that you ran into at pre-balance time, because it's gonna save everybody time and money at the end of the project when they can understand where we started and especially where we're going to end up. Tim, you got any final statements?
No, Eric, I think you have covered just about everything, man, and added a few things. Once again, I've learned even more after my article, was speaking with you and some of the good points you brought up. So I really appreciate it.
Absolutely. Now we got some time for some Q&A, guys.
Thank you so much, Eric and Tim. That was very informative. I am just going through the questions, and as a quick reminder, everyone, if you have any questions, please use the Q&A button to send them through. Starting with Donald's question. Donald says, I usually take pre-demo readings in the spec, but with very little details. This makes it very difficult to bid competitively. Also, I bid so many projects, it is difficult to request more information on every project. My question is, how can we educate the engineers to be more specific about what they want during pre-demo?
Yeah, absolutely. I think that's something that we've all struggled with over time is, the ambiguousness of, what data do you need or how far do you want me to take this? The best thing that I've found in the approach is definitely communication, right? I've gone to engineer's office, I've brought sandwiches, we've sat down and talked, but education to, the mechanical engineers is huge. And sometimes they don't even understand what they're requesting. You know, we did a lunch and learn one time with an engineering firm where they brought in, you know, a bunch of their PEs into a room, had sandwiches, we talked, but they didn't even understand when they asked for a static profile. They're like, how do you obtain the static readings of a static profile? You know, how to explain how we drill into the doors of an air handler, how we stick our tubes through, you know, some of the problems or issues that we can come up with at those times. And so just kind of talking through exactly how we obtain these readings was a huge push for these guys to understand, like, hey, when I'm writing this down, this is what I'm asking for. So I think education, getting with them, having open lines of communication with MEORs is probably your best path forward.
I would also add in the the bidding process, and I know it's difficult, and I've done a little bit of estimating over the years, but they're once again going back to all these notes, and they're going to be on the demolition pages. I don't know if they always get caught by the estimator. The estimator is doing counts. They're looking at specs, all of these notes on every single, and in this case, mostly the demolition pages. They're going to give you information on what the engineer is looking for. I'm seeing that more and more notes on the demolition sheets. They'll come in handy.
Thank you so much, Eric. And Tim, there was a comment by Steve. He said, additional recommendation, record the contacts you had at the time of pre-balance that can help you later when you return to access challenging locations. Perfect. The next question that we have here is, if the purpose of pre-demolition reading is to establish a baseline for an existing system's performance just before construction, wouldn't it make more sense to conduct them during the early design phase so the engineer can incorporate the data upfront without needing to revise the design later?
Yeah, and you know, I probably didn't do a great job of explaining that, but you know, when we talked about it in the beginning, I had the slide. Of course, it's not working right now, but we had that slide of the, you know, same side of a different coin, or it basically means, like, you know, we have different phase references to the same scope of work. So we do what's called pre-design surveys. So before design, we're going in there and taking those readings. Here in the state of California, when you have a healthcare project, we're doing pre-design readings. That information is going to the engineer, and then we're actually doing pre-demolition because they need those readings. When you're doing before demolition, they need it 6 months. That information has to be no older than 6 months. So typically we go through, do a pre-design survey, hand that over to the engineer, and as they're gearing up for construction, we're going back in to do a demo. And, you know, we're looking at, did anything change from that pre-design survey? Because that is the assumptions that they're making for the post balance. And so now we wanted to ensure that nothing's really changed from the pre-design survey to the pre-demolition survey. And I totally agree with you. It makes way more sense to have you guys go out. Typically, when we're doing it for an engineer, for a pre-design, we are contracted under the engineer to go get those readings so they can do their design.
Beautiful. Question is, in which scenarios are pre-readings unnecessary?
Sorry, can you say that one more time? When it's necessary?
When is it not necessary? In which scenarios are pre-readings not necessary?
Yeah, you know, they're probably, if they're doing a complete demo, like a complete gut where they're going with brand new equipment, brand new ductwork, they're not using anything existing. It's not affecting any other areas. So if you had a building that say is 20,000 square feet and they're demoing all ductwork, all HVAC, and they're putting all brand new, it probably doesn't make sense to have a pre-demolition or a pre-balance report done, because it's all going to be brand new. So you're not reusing anything. It's not affecting any other areas. And so I would think that would be a component at which you probably wouldn't need to do it.
Okay. Thank you for that, Eric. I'm just scrolling through to just see if you have. There's a new question by Bill, and he says, if we have a job that we're doing a pre-demo for, and the engineer is asking only for readouts, no data or static pressure profiles, should we still do it just for data collection on our end?
Yeah, I mean, I think we touched upon that in one of our slides, but definitely go out. I highly recommend, even you can make the case at the end of the job, if something goes awry and readings aren't coming back the way that they were at the pre-balance or pre-demolition readings, you can make the case that, hey, you never asked for it. But it doesn't carry much weight. So I don't think it takes very long to grab some type of information, whether that's a static pressure reading. I mean, you can even take static pressure readings if it's a VAV system down in the space. Like, you don't absolutely have to go to the air handler. You can go to a main trunk line, drill a hole, get a static pressure as a reference. But I think it's incredibly important to do so because of the fact that we live in this invisible world. When we just say, hey, we didn't have it, but something changed, we definitely get the cross-eyed look at us, test and air balance guys, like, oh, sure, something changed. And it's like, no, something did change. Like, my readings are different. But if I can't prove it and I don't have a reading to reference back to, then it just almost seems like, we're pulling the wool over their eyes, like we never took the readings. So that's part of what I think is important to do, just as an industry standard, to make sure that everybody knows we're on the up and up.
Thank you so much again, Eric. There is the other question that we have is, do you ever suggest or recommend pre-demo tab when providing proposals and you see that they are going to reuse equipments or duct systems, but nothing is called out for pre-demo testing? I can read that again if you'd like.
I think I understand the question. Is it, do we become, or do we recommend the pre-demolition reading? Is that what he's saying?
Yes. Do you ever suggest or recommend pre-demolition tab when providing proposals?
Absolutely. If you see a project where they're reusing and they're not taking pre-demolition or pre-balance readings, we always go to the engineer and say, hey, I think it's a great idea to protect you and us, because basically there's a lot of assumptions being made right now of how the equipment is operating. If they're just looking at, when that building was designed and they're looking at, what the equipment did when it was brand new, there's definitely degradation. There's definitely going to be problems. If we can identify those at the beginning and we just need to make a point to them, it's going to be a lot cheaper, for us to come out now and show you all the problems and then get to this final balance and try to figure out what's going on. So highly recommend communicating that, going back to them. And then if you have it documented too, I think that's also a great component. If you document it, send it to the engineer in an email and say, or an RFI, say, hey, I think we should do this. Now on the backside of it, they say, no, we didn't need to do that. We don't want a pre-demolition survey. That's just extra cost. We don't see the benefit in it. When something goes wrong on the backside in the post balance, you can reference back to it and say, hey guys, we did mention to you guys that it would be a good idea to establish a baseline for all this equipment. Understand that, now we're on the post balance side of it, and it's, there's going to be some change orders. There's going to be some added work for us. Just understand that, there's going to be a cost impact because we didn't identify this in the beginning. And now we have to do investigation. We have to, work together to work through getting to a completed final balance. Sorry, Tim, I feel like I took over this Q&A.
No, sir. I think you're qualified to answer these questions better than me, but I'm listening and learning like everybody else. So thank you.
Absolutely.
Gentlemen, I think we can go ahead and just take the last question. The last question would be, would pre-reading be required on a like-for-like equipment replacement when duct tape is not being modified?
I've got a point of view on this one, Eric, and I'll see if you agree with me, but if the unit is being replaced with an identical type style unit, I would think that and the ductwork's not going to be modified. I would think that the pre-demo readings would not be necessary. Do you agree with that?
Yeah, I mean, I could see a case being made for that, but also just, I guess the other component of that is how old is the equipment, right? What are you trying to reestablish? I think there's some components, here for rip and replacement for schools, let's say, we do go out and we do a pre-balance. It's not the whole thing, it's not the whole kit and caboodle, but we are trying to take total airflows, we're trying to take just operating statics, those type of things prior to the replacement of it. I think it just saves you in case, something isn't, if the teacher was comfortable, all of a sudden you come back, you have noise problems, you have different things happening. It just saves you for a pretty cheap cost. It saves you on the backside of it to say, hey, this is how it was operating prior. And now are you reestablishing a new design? Sometimes they are reestablishing a new design. So let's say it was 1500 CFM. That's what the fan was supposed to do. And they're putting a new fan on, and that's what they want the post balance to be. Sometimes we're seeing in schools, though, is that they're saying, no, we want to go back to what we had. So if we had 1000 CFM, we don't want to go to 1500. We want to go back to 1000.
Right.
It just depends on the project. But I always see a component for it being, if even in a rip and replace standpoint, I think we can find things for them that it adds value having a pre-demolition survey.
Good point.
I think with that, it can be a wrap for today's webinar. Thank you so much, Eric and Tim, for an excellent presentation and discussion. And thanks again to our sponsor, Integra. To everybody else, the audience, thank you so much for joining us today. We hope you found the session insightful and full of takeaways you can bring back to your project. Before we go, a quick reminder to save the date for the 2025 AABC annual meeting. We cannot wait to see you there. And if you've got a story, solution, or insight the tab industry needs to hear, you've just got 7 more days left to submit your abstract. So head over to aabc.com and submit your proposal under the 2025 ABC annual meeting section on the website, because we'd love to see your spotlight for work. And again, thank you so much, Eric and Tim. Everybody have a great day.
Thank you.